In this video, we'll be working some problems that involve angles given in radians. Recall that 180 degrees is the same as pi radians. Our first example, we're asked to evaluate 4 sine of pi over 4 plus the sine of negative pi over 3. Now my first step would be to draw the reference triangles for these angles. Since pi is 180 degrees, that's this top semicircle, divide that into 4 equal parts and we see that our reference angle is 45 degrees. So a 45-45 right triangle has sides that are in a ratio of 1 to root 2. So we put those side measures on our reference triangle and we're ready to go with that term. Now for this term, pi is 180 degrees, divide by 3, that means we're talking about a negative 60 degree angle. So if we draw our reference angle, negative 60 degrees, that'll put us down in quadrant 4. If the reference angle is 60, then the side opposite that angle is root 3. The side adjacent is 1, and the hypotenuse is 2. We need the negative on this vertical side because it's below the x-axis. Our horizontal side, though, is a positive one because it's to the right of our y-axis. So those are the reference triangle sides that we'll be using. So our problem has 4 multiplied by the sine of pi over 4. So 4 multiplied by, and then my sine is opposite over hypotenuse. So 1 over root 2, which rationalizes to root 2 over 2. Now for this term, I want the sine of my reference angle. So I want opposite over hypotenuse, which is a negative root 3 over 2. Both of these terms have 2 in the denominator, so I have a common denominator. So I can just add. And my answer for that expression is 4 root 2 minus root 3 all over 2. Now remember, you cannot combine these two terms because they're not like terms. My next example, I have the sine of 13 pi over 4 plus 3 times the cosine of negative 5 pi over 3. Now the way I would look at this, 13 pi over 4 is the same as 3 1/4 pi. Now I know pi is a semicircle, so if I count 3 1/4 semicircles, there's 1 across the top, and then 2, and then 3, and then 1/4 of a pi would put me down in quadrant 3 with a reference angle of 45 degrees. Since I have a 45-45 right triangle, my sides will be 1 root 2. Since I'm going left, this side has to be negative, and I'm going down, so this value is negative, and I have my reference triangle set up to work this first problem. Now for negative 5 pi over 3, again I would change that to a mixed fraction. Negative 5 pi over 3 is the same as a negative 1 2/3 pi. So a negative 1 pi, negative angles, remember, are measured in a clockwise rotation. So a negative 1 pi is just this bottom semicircle. and then 2/3 of a pi more. 1/3 more would put me in this quadrant, and then 2/3 would put me in quadrant 1. So I have my reference triangle drawn in quadrant 1. Pi over 3, remember, is 60 degrees, so my reference angle is 60 degrees. So the opposite side is √3, adjacent side is 1, hypotenuse is 2. All of these sides are positive since we're in quadrant 1. Alright, so I want the sine of this reference angle, which is opposite over hypotenuse. -1 over √2 rationalizes the denominator to a negative √2 over 2, plus, and then my second term I have 3 times the cosine, so I wrote 3 times, and then I need the cosine of my reference angle that I've drawn. Cosine is adjacent over hypotenuse, so that's 1 over 2. I have a common denominator of 2, and when I multiply here I get 3 over 2. So this expression simplifies to negative √2 plus 3 all over 2. My next example, I have cosine of a negative 25 pi over 6 minus 2 times the tangent of 4 pi over 3. Now let's look at the first term first. 25 over 6 is the same as 4 1/6. And this is a negative angle, so I need to move in a clockwise direction. 1 pi would be this lower semicircle, so there's 1 pi, 2 pi, 3 pi, 4 pi. And then a sixth is the same as 30 degrees, which puts me down in quadrant 4 with a 30-degree reference angle. When I have a 30, 60, 90 triangle, the side opposite the 30-degree angle is 1. The side adjacent is √3, and the hypotenuse is 2. My horizontal side is positive because it's to the right of my y-axis, and my vertical side is -1 because it's down below the x-axis. Now I'm ready to use this reference triangle for my problem. Now in this one I have 4 pi over 3. That's the same as 1 1/3 pi. It's a positive angle, so I'll start with my positive x-axis and move in a counterclockwise direction. 1 pi is my semicircle, and then 1/3 pi is the same as 60 degrees. So my reference angle is 60. So the side opposite is radical 3, and the side adjacent is 1. The hypotenuse is 2. Now I need negatives on both of these because to the left is negative and down is negative. So now my reference triangle is ready to use for the problem. So my first term, I need the cosine of my reference angle. Cosine is adjacent over hypotenuse, so I have √3 over 2. On my second term, I have 2 times the tangent, so just copy that 2 times, and then I want the tangent of my reference angle. Tangent is opposite over adjacent. So negative √3 over -1 simplifies to just √3. So this is 1/2 radical 3. Subtract 2 radical 3. I can combine those and get a -3 radical 3 over 2. or negative 3/2, radical 3. Now let's look at a word problem. The latitude of Los Angeles is 34.05 degrees north of the equator. How far is it from Los Angeles to the equator if the diameter of the Earth is 7920 miles? Okay, first of all, we know that if the diameter is 7,920 miles, then the radius will be 3,960 miles. Just divide your diameter by 2. If we change our degree measure to radian measure, then by definition of radian, all we need to do is multiply the angle that's in radians times the measure of the radius. So to change 34.05 degrees to radians, you multiply by pi over 180. So that gives us 0.189 pi. Now my angle is in radians, and all I need to do is multiply that angle measure, that radian measure, by the radius of the Earth, and I get 2,353.367. Now my problem is in 3 significant digits here with our measure of the diameter. So let's take this to 3 significant digits, and we get 2,350 miles.